Hey, this is David D. Hilster. Good evening, good morning, wherever you are. I know I've got people all over the world sometimes, but I am starting and am live. And I know when people are watching this recording, I see these with some of the people I know who do YouTube channels, and they don't say a whole lot. They stand there and look at things and check things, and it is extremely boring. But this is David D. Hilster. I'm with the Dissident Science YouTube channel. I want to thank all my new subscribers. I get a lot of subscribers every week, some new ones, and do appreciate it. I'm hoping you're here because of the same reason this channel exists, because you want to become science woke. You want to know more about what's going on in science, because you really don't believe in necessarily everything that's been coming out of big science, and you have questions about things that may be establishment ideas. And no, this is not some channel about flat earth or anti-climate change or anything. This is a channel based on my knowledge of hanging around some of the most incredible scientists for the last almost, I guess, more than 25 years, coming up to almost 30 years, and hanging out with these people who have worked outside the mainstream, who have found problems, identified those problems, and fixed those problems. So if you have not, if you're coming to this live, you want to make sure you go down, right down below, right down there, click on the subscribe button and the little bell next to it. Every Friday I try to come to the world with the live chat, and people do have regular people who show up here. And I always have some topics I'm going to be talking about, and today I'm going to be talking about a couple of things that's going to be interesting. One, about a conversation I had with somebody who is sort of lives between the dissident and the mainstream. This guy was a really interesting person to talk with. We had a lot of conflict from the beginning when we were first talking, but in fact we did get over the problem of sort of how do you say, defending our territory, etc. And it turns out that we had a great conversation, and he actually turned me on to a guy's work. His name is Dr. James Sung. He got his PhD, I believe, in physics, but I'll take a look at it. He has a website. This gentleman helped him put up the website. But it was very interesting, the conversation I had with him, and how somewhat we both got on the defensive. He sort of was that way in the beginning, but it turned out to be pretty fruitful, because I always try to, you know, not to attack and say, hey, look, let's look into this and let's talk about it. The second thing I'm going to be talking about today is sort of a conversation to give you a little bit of insight on what my dad and I are doing with our particle model. What do we dissidents who actually are working on an alternative model for the universe actually do? Why do we say and do things? Why do we say and do? What do we do? What do we say when we're trying to put together and talk to each other and put together a model? Where are we? What's it like? Because all we know, really, if you are a person that's new to this channel, or you're not a person that's been around people who've been working outside mainstream for a long time, basically it's something pretty, I think it may be interesting to sort of go behind the scenes. In fact, I'd like to maybe even film some of those sometimes, about my father and I's conversations. What is it like to be, you know, one of the groups, not the only, or one of the people or groups of people working on new models for the universe? And I think that would be quite interesting. Let's see how we're doing here with some people, if we're getting them to show up. I turned it on a little bit early today so that people would know. Let's see if we got some. Turn down my volume here. Oh, I got a couple people already on. Hello, Lisa. Hey. And we've got a duplicate. So great to see you guys. Lots of always fun stuff. Today I'm going to be talking about, if you just got here, but oh no, you've been here for a few minutes. More people showing up. We get about anywhere from 5, 6, 7 people, all the way up to 15 people, which is pretty good. I've got about 26. How many people do I have on subscribers now? 2745. So yeah, we have you know, that's pretty good. You know, it takes like about 10,000 before you really start getting a bigger audience. But this way, it's more intimate. I can actually answer questions, but no problem. I'm planning to do some more things. I've been working on a couple of projects that will bring more people in this direction. One is going to be getting into progressive politics area, because I'm progressive politically, and I think there's a lot of things that people who are politically who are progressives or politically woke would be very surprised to find out that, in fact, big science is pulling a lot of shenanigans. And it's a lot different from big science, big politics. Big politics has a tendency to be run by big corporations. Big science, they can get big money, but it's done in a lot different way. There's not profit to be made in doing gigantic particle accelerators. I have arguments with people who like the particle accelerators, like the Large Hadron Collider, and these people will argue that no, the politicians and the people are really giving money because they want to know really what's going on in the universe. I'm not so sure about that. A lot of my comments actually that come with people who actually comment on my videos, they'll say, no, Dave, I don't believe your theory, which is my theory. Is it's basically because they want something. The atomic bomb, the Manhattan Project, was what launched physicists into superstardom and superpower, because they were the ones who held the keys to, the destruction of the planet politically, or with the atomic bomb. And so since then, governments are willing to gamble money to be on the edge, because being on the edge may mean ultimate power. Now, I think that's still what's happening, but some people may disagree. We have Tyler Tom. It says, hi Dave, did you find it challenging studying physics as an autodidact? Can you describe what helped you as someone without formal physics training? I'm sure your mathematics background was helpful. Wow, really good question, Tyler. I really appreciate being, that question. That's quite interesting, actually. And I'm sorry, we're a little discombobulated in our house. We are actually we tented our place because there were some, I guess, of small beginnings of termite stuff, and so we've been out of our house for 3 weeks. And so there's a little bit of movement and people around that are normally around. But that's a really great question. It's basically, how challenging was it to study physics? Well, first of all, I was a kid that loved science. I did science projects. I won some project awards, not for anything like stellar. I was more mechanical. I made things like time-lapse photography machine. You have to remember, I'm almost 60. I'm 1 year away from being 60 years old. So this was in the 1970s, 1960s, 1970s, when I was a kid, a real young kid. I grew up with the Apollo moon missions, and I loved it. I loved science from the very beginning. I was an artist too, so I actually lived on both sides. Things like right there, you can see the Dissident Science. It's a pretty nice logo. Did all that stuff myself. So I have a lot of, I have both sides of my brain, which I also think help. But I've liked science from the very beginning. I was always making stuff and experiments. I made a time-lapse photography machine when I was a kid. My dad helped me with it. He was an electrical engineer. I made a pipe organ from all kinds of stuff. I made a balloon launcher that launched water balloons for 500 feet or something like that. But I was much more mechanically inclined. But yeah, I was good at mathematics too. I took calculus in high school at the time, which was not very common, and I got my degree in advanced calculus. So, I'm a computer scientist. Actually, I'm a computer scientist by trade, but only took one programming course. I ended up in artificial intelligence area, and so I guess, I have been tested, and, it's a high IQ, that kind of stuff, but I'm not really impressed by that so much. I don't go around saying that, but I guess that helps. But I think it's because I have an artist side and a science side, where you really use, they say, both sides of your brain, if that's true or not. And so, my love of physics and it was one thing. My love of science was one thing. The other thing was too is I met. It really started in 1992. My wife had a clothes store because she's a clothes designer. She was from Brazil, and I was living in an artist loft. I was working in the artificial intelligence group, and it was wasn't at Space Park at the time, but I think it was in Southern California, and there was a Brazilian flag out there. It's a story that I tell many times. Basically, there was a gentleman who walked in, saw the Brazilian flag, said he was trying to do stuff with acai, which is that berry that's from Brazil. It was way ahead of his time. He was right about that. But then he saw on the wall, he saw some of my art. If you haven't seen my art, you can go to dehilster.com, DEHILSTER.com. Take a look. I've got some of my stuff there. You know, I was represented by the LA County Museum for a number of years as an upcoming artist. So, you know, I'm an artist. So he saw the stuff on the wall and he goes, "Oh, who's that? I love the art." And the guy said, and my wife said, "Well, that's my husband." "Oh, he's an artist." He goes, "No, he's sort of a scientist. He makes a living, but he's also an artist." And then at that point, the guy said, "You know, my father-in-law, Dr. Riccardo Carruthers, who's a physicist, is needing somebody to help him get the word out on his work, which shows Einstein wrong, and shows a correction in special relativity, comes up with new equations that are quite interesting." And so that's how I got into it. And my first readings of that was, of course, it was math, but unfortunately this guy talked in math and I needed to tell a story. It took me 2, 3, 4, 5 years before I could explain to the world what Dr. Carruthers found. So I read the math, I read the stuff, but I'm a big picture person, so I'm not as interested necessarily in the details, although details are very important to certain things that we do. And so I would say to everybody who is learning stuff that, yeah, you know, first of all, let's just say this. You don't need a physics degree, because physics degrees, you're only going to be indoctrinated with what they're going to be telling you, so you're not going to have an open critical mind. And if you do, they're going to drum you out. That's just a fact. Carruthers had some students that wanted to do his experiment to show special relativity wrong. Pretty simple experiment, but they're all summarily sat down in the office, closed the door, said, "Do you want a degree in physics? Then you won't do this." And the other thing is, too, today and age, folks, there are people writing books about how there is so much knowledge on the internet today that you can read and teach yourself, that you can pretty much learn almost anything. My daughter is in theater, and I didn't know anything about the audition process, and I went online, and there are hundreds, thousands of videos that will not only show you what's in there, what you should look out for. People, you can learn almost anything. If you need to fix something, if you need to do anything, the knowledge is there. We have, for the first time in our lives, in this little box, all human knowledge. And with that, you should say to yourself, well, if I'm interested, I can learn about it. I can understand. Now, the other side of that, and I know there's a lot of things here I'm going to get to you, but one of the things is that this idea that you're saying, well, can you describe what helped you, someone without formal physics? Here's the big conundrum, and this is one of the things that we know quite well, and I say it all the time. I've got a meme that even says that meme, and that meme says, you know, it's not the complicated. Let me see if I can find that while we're talking. I've got my browser and stuff, but I have a meme and it says it quite well. The whole thing is that when they tell you this whole thing that they feed to us, that you have to be, you know, physics, you don't understand it because you don't know how it works. In fact, if you look at a few of my the videos, if you're watching this recorded, look at the videos just before this, and I talk about that. I talk about how they say it's very complicated. There's one where the two Danish physicists who are disputing the signals that were received, supposedly found in the LIGO detector, and that's for gravitational waves, and they're challenging it. Well, they spent, in the article about that, they said they spent 2.5 years trying to teach those people, teach me, teach you, teach anybody else, how come they're right. They do not even have in their consciousness the ability to say, oh, well, yeah, this could be wrong, because there's too much at stake. So here it is. Let me bring this up for you. I make memes here. Here we go. This is me. You see I love this place. I'm going to probably be moving next year. We need a new place, but I love this, my office here. But it says right here, this is what I think I say this quite well. The universe isn't complicated and paradoxical. Our theories are, and this must change. And I think that is, in a nutshell, what really happens. So Tyler, when you ask the question, can you describe how it helps someone like you without formal training? Well, the problem, it's really simple. Most architects, most artists, most musicians, most philosophers, and even most scientists, not the theoretical kind, will tell you, if engineers, computer science, the best and most important ideas are very simple and can be easily understood. One of the things is, when I was in architecture, I have a degree in mathematics and architecture, yeah, the buildings and all that kind of stuff, because I tried to combine art and architecture, and turned out that's not didn't work for me. I do it a different way. I just do them separately. But my architectural professor, he used to say, if your mom can't understand the big idea of your building, it's a bad idea. You know, it's either a courtyard building, or it's a veranda type building, or it's a monument in the landscape type building. These kinds of things have to be very simple. The big idea has to be simple. And one of the people that talks about that a lot is, in fact, Alexander Unsker. Alexander Unsker is a person who I think he's Alexander Unsker. You can just look him up. He is a great person. He's one of the books I recommend. I talk about him all the time. And that is, he is a physicist from Germany. And he is on a kick right now saying, look, we have to simplify things. We absolutely have to simplify the world. Here he is. In fact, one of the projects I'm going to be doing with sciencewoke.org, I hope to work with him because I've been putting his book out 1,000,000 times. Here's one. You should read it. This book, if you look at it, I can't find any math in it. There's no math in here. So the whole thing is there are a lot of people out there like him, like myself, who are in fact looking. In fact, look what he says here. I'll see if I can get this up here. It says some of his titles. Sorry. I got an old computer here. Contemporary figure. Here we go. Yes. Also, Einstein's theories can be understood. We can disagree on that one, actually, but that's okay. I don't throw away a person because of one thing I disagree with. The most interesting papers are found 50 years old in 50 years old physics journals, and even older. There is lots of unsolved yet fundamental problems in physics. Absolutely, we don't know what gravity is. We don't know what light is. So we're in a place. Contemporary philosophy would be rather ignorant about its history. Absolutely. These are his sayings on his website. So you can see there. And what he is saying is it's got to simplify. We have to simplify things. The complicated standard model, again, you're going back to your question, can you, how with someone without formal physics can understand this stuff? You can't. It's paradoxical. It's, like I said, it's ununderstandable. It's incomprehensible, because when you have even Einstein's theory of special relativity, you have something that, let's see if I can make sure. That's a problem when you put up things live here. Look at that. I'm going to the wrong place. There we go. Anyways, I have, what I was saying is, when you are, I lost my thought. I'm trying to show you things, but the whole thing is that when people are saying you have to understand this, it's very hard. When you hear Neil deGrasse Tyson say, I'm just going to go away from this here. You know, the universe is really complex. It's really bizarre. Quantum mechanics is really different. The universe is like, you know, they wanted to make it a magical place for a number of reasons. One, it attracts your imagination because it's going to be magic. It's going to do things that are impossible, or we'll be able to do those things we want to, transport to any place in the universe that, like, physically, just transport ourselves there. Those kinds of things, or whatever. And so that's one thing, but it's also that magic part of it that's really hard to understand, or it's really mysterious, and we're not sure we'll ever understand it. It's to make them they put themselves in a position way above you. So they say you're not going to be able to understand it, and the only way you understand it is what I call is capitulation. You don't understand it ever. So it's not a case that you guys out there who are not physicists, who are trying to become science woke, have to understand the particle model. I'm telling you, Alexander Unziker, who has a PhD in physics from Germany, who talks with the brilliant guys, supposedly brilliant guys, that deal with the Standard Model, who win Nobel Prizes, like David so-and-so, don't even remember his name, I don't really care, because he's not really a nobody in history. He will be, even though he's won a Nobel Prize. Those people, the only way you're going to understand them is to just say you understand them. So you will not understand it. It will be paradoxical, just like special relativity has paradoxes in it. And those things will tell you, they are going to tell you, you're not going to understand it. So this, again, I guess my answer, a very long answer to you, Tyler, is that no, you don't have to be a physicist to understand it, because it should be much simpler. We don't know what gravity is. We don't know what light is. We don't know what electromagnetism is. We don't know what magnetic field is. We don't know how that interacts really with the atomic structures. Quarks, W particles, Z particles, the Higgs boson, you can throw them all out. And new models are being proposed out there. My father and I are working on one. So let's go for David is, what's your opinion on time? Very good question. Time is something that's not real. You can't take space, which is three-dimensional place, and put it together with time and call it space-time. That's just an absurdity. That's a mathematical construction. It has no physical reality, means nothing. And all this bending of space-time, or there's this foam of space-time where things pop in and pop out of it, forget it. Throw it out of your heads. We've got great scientists around the world who are science woke, who are not tied to their salaries to anything by saying that from being a professorship. And some of them have actually had to teach stuff they don't believe in, but you can throw that away. But time has to do with movement. That's it. Time is with movement. Time, in fact, by Dr. Glenn Borchert, a person that you should read. Dr. Glenn Borchert, I'll put him up here too. I'll get to Amazon. He has really great books. The Infinity Universe Theory. I'll look that up here. This computer is slow. I need a new computer, but don't. There we go. Hold on. Infinity Universe Theory. Man, they just don't have that. Infinite universe theory. That's why I got it wrong. Okay. Here's a person you can read. Let's get it over here. There we go. So that's a person and somebody you should read. And we were talking about time. His definition of time is one word: movement. And if you think about it, and my dad's and his channel, you should check his channel out, the Particle Guru. You can go to, just look up Particle Guru and subscribe. He's got 3 videos coming out that are just gonna, I'll tell you, everybody here subscribe to him. He's got 3 videos. Listen to what he's going to talk about. E equals mc squared, The reason c squared is what he thinks is the G2 particles going at c squared. He talks about inertia. Inertia is like this idea that once you put a body in motion, it always stays in motion. It's Newton's, I believe, first law. He's talking about physical interpretation of that, not some my dad's very physical, talking about the physicality about that. And he's going to talk about one more thing. C squared and inertia. I can't remember, but you got to subscribe to his channel. He's got 3 things that are coming out there to be just fantastic. So my father's also talked and thought about time. We have other people think about time. Time is needed for us to measure movement. Things move. Time, just imagine this. Here's the way I would put it as to what time is. Imagine nothing moves. Nothing in the universe moves. There's no moves. There are no time. There's no clocks. Nothing's happening. Why do we have time? Something is moving. A train is moving. We are moving. Time isn't moving. We have a clock that's moving, and that has a mechanical, it's in the mechanical world in which we live in, the physical world. We live in a physical universe. Don't get this idea that there's non-physical things. There aren't. That's at least my opinion and many other people's opinion. And so what you have is these, everything in the universe is moving. If you read Glenn Borkert, you think about it. This great globe, for those who you don't know, this is made by Dr. James Maxwell. The Earth has been expanding, and he made me this model. And the Earth was about, what, half the size with the dinosaurs? That's why they're so big. Anyways, this looks static. It's just sitting here, right? No, we all know that inside this is made of atoms. The atoms are in movement. There are things going around the nucleus, what you call them, electrons, whatever you want to call them. There are things with nuclei, like little solar systems in here. This is in constant movement. All matter, according to most of the dissidents, or most of the science woke, or most of the critical thinkers, including people who have PhDs from MIT, from Stanford, from Harvard. Those people are in our group. These people will say, yeah, everything's in motion all the time. If everything's in motion, that means things that this time, we use it to measure movement. The only way to measure movement is you have to have time. You have to have distance. And so it doesn't make sense. So we have this idea of time that comes from, it has to do with movement. So that's the answer I would give you. I would also say that time, in more of a colloquial sense, is something like our way of putting some standard to movement that's a steady movement, like in a clock. And we create, if you think about it, a clock is a steady movement. You don't see clocks going and slow and fast and slow, slow, fast. A clock is meant to be a mechanism that moves in a steady way, and in a way that we call something a second, a minute, an hour, a day, a year, etc., a decade, those kinds of things. And so that we set up a mechanism of movement so we can measure other movement. Because it's not interesting. The universe is absolutely, for instance, this is sitting here doing nothing. I mean, relative to me. Let's just take our frame of reference here. It's just sitting there. Now, you're going to say, well, what does time have to do with it? Nothing. You know, the only thing you could say is time, these are made of atoms. Atoms have a half-life. Eventually this will not be the same thing in a cajillion years or whatever. Okay, yeah. But in general, time is only interesting because of movement. Okay, I hope that answers that question. My view on time is an emergent property. That time is an emergency. My view on time is... I don't get that because... let's see, of change. Well, yeah, so Fractal Woman. Oh, Fractal Woman! Hello! Oh, I don't know if you're still here now. Oh, you are here. But there was a lot of people discussing here. Well, hello. I won't give her your name, but anyways, she is a member of our CMPS. I met her in 2017 in Vancouver. Really interesting, her work. I think Fractal Woman, she has a YouTube channel. So I'm way behind, folks. Gosh, I'm just rolling on because, you know, I'm getting more people here. It's really great to see everybody. So we're talking about change. Yeah, Fractal Woman, very agree with, much enjoy your videos. Fractal Woman, I agree. Very much enjoy your videos. Okay, that's good. Oh, you hear my daughter singing in the background. Oh my goodness. Yeah, she's quite a star actually, but everybody's home tonight. Normally this is my night where everybody's out. So, and you, okay. Did you find reading the peer-reviewed papers in physics particularly to be too dense for a while? I do read them, and I will tell you my experience with that. First of all, you have to go into these things with an idea that you're not necessarily going to understand the math right away. And the other thing is too, you have to understand that sometimes it's baloney. It's garbage, because when you do go through the math, we have people will here's the way I look. If these people are writing about something like the unicorn world of the standard model, I'm not going to read too much about it, because I'm not going to waste my time trying to figure out what unicorns they are talking about. But if it's something like the LIGO experiment and you see things, well, what you have to do is read through it. Just read through it and skip things you don't understand. Just skip them. Go through it again. Go through them again. Step back. Try to get a big picture of it. Are they describing something in a way that you can understand? And then start to look at the math. You can get there. I think you have to be really careful today. I think what I would say to any of you who are trying to become science woke, who are new to this, who aren't in the dissident world, somebody like Fractal Woman, I know she's been in it for a longer time. When you get to those points, you learn what's just not worth reading. And you just say, you know, I believe neutrinos are a joke. They were invented, and of course, you know, why even read about them? Whereas the LIGO experiment, I want to see, you know, how they do it, and try to understand it. So you just got the way I go and I approach that is I look through them. I can read an article normally in a couple of minutes, even if it's really, really technical, and get an idea. And once you read a bunch of them, you start to get some idea. But you know, the idea of delving into lots of these, I don't. The only time I do is when I actually think there's something worthwhile, or I want to argue against something for the purpose of teaching something to someone. But I don't go reading it, and that's not because therefore David doesn't read these things, so how could you be against it? No, the things that I look to show things wrong are to look at other scientists and the work they do and read their work, because they have studied it. Look at Dr. Edward Dowdy from NASA in our group. He has shown that yes, when he looks at starlights that is supposed to be bending because of general relativity, it doesn't. The only time it does bend is when it's in the corona of the sun, and the corona of the sun is full of mass. That is not empty space, and light definitely is affected by mass. So that's a fact. So when I look at the papers, if I do want to look at them, I'm interested, I go through them real quickly. I try to read the beginning, try to understand what the big picture is first. Take the big picture and then try to go down from that, each layer. Go through it again. Go through it again. Sometimes, and go through fast. I don't like go through word for word. I skim through it. I read it. I get a gist of it. I go to the beginning, the abstract, the conclusion. I look at some of the diagrams, see what's going there. So I process it. And I'm a very visual person, so I do construct things in my head. Maybe I have a affinity to be doing that. Maybe I don't realize it. I don't know. It could be. John Owens, evening. How about that crater found in Greenland? Yeah, that's pretty cool. Hello, I'm new. A friend of Lisa Hausman sent me over. Oh, hello, Kathleen. I hope you're still here. And I do apologize, I'm behind. I do appreciate it. For all of those who are coming to be Science Woke, we do have a website that is going to be really cool, and I want to show you some things here. Let me make sure I'm not losing anybody here. My goodness, lots of people talking here. Anyways, let me show you all you guys who are new here. We are working on a website, and it's super exciting. I continue to work on it, and I'm not going to launch it until it's ready. But because you are here, you can see it. And in fact, I am going to make this a little wider. It is sciencewoke.org, and there you go. And if you can find out our login, you probably won't, because I'm a computer scientist. I have a password that's about this long, and I only can cut and paste, and I have that in a super safe place. And the chances of you randomly coming up with that are, you're gonna be transported to another galaxy before that happens. So I'm not gonna let you see my login here, because that would be dumb. And let's see if I can get in here. There we go. And we'll get to the site. And I want to show you some new things. So those people says, oh no, Dave's going to show that again. I've got new stuff, and actually a new category because of one of the people. So let's take a look at this. And Science Woke. So this will become, I'll move over here and give myself more room. There we go. Science Woke. I'm going to get it up here. The reason I see that is because it's still not going wide enough to get me the. Come on, pop open. There we go. Oh, right. That's all right. I can live in that little space because I can frame myself. Here we go. So there's a start here. There are problems in science. I've showed this before. We have scientists, the new scientists. These are not anybody in the mainstream science. We have new theories, and there are quite a lot of them. We have a lot to put in there. We haven't filled them out. Here's the new area. They're called stories. And this is just great. We're having weekly meetings by the CMPS, people who have been in the Science Woke, and we have stories, fights with big science. We have lots of stories where if you are a political progressive, for instance, I don't care if you're conservative or whatever, but if you're, whatever your politics are, but I think we're all starting to get the idea that big corporations, people with lots of money, they sort of manipulate the world, and they're trying to get things in their directions. And if you try to fight, if you are, for instance, in the United States, and you are not a Democrat or Republican, you're independent, like Tim Canova here in Florida, and he's got great things that he wants to do for we the people, well, he has a real problem because they gang up on him and drum him out. Well, we have fights in big science, and those are going to be articles. We're also going to have eureka moments. I've had at least 3 of them. One was with Yonel Deneu's underwater experiments that shows us how magnetic magnets work, and the magnetic fields. They're actually flows of stuff. That's really interesting. That was another one was Infinity with Glenn Borker, and the other one is my father, who solved the wave particle duality. Well, then not a big thing. Then the big picture. I've got a lot of big picture articles. I'll show you a little of that, and of course just news. But this is really cool. So fights in big science. I don't know how many I have here. Halton Arp and his peculiar galaxies. He was actually he was looking at galaxies that look really strange, and then he was finding out that, you know, the quasars, if you ever heard of those, doesn't matter. Quasars are these things that are supposedly in the universe that are traveling at super fast speeds. Well, the quasars, he had visual evidence that they were linked to galaxies, often shooting, they even think they shoot out of the center of galaxies. And they had a problem with that because redshift, the Big Bang, that everything's moving away, and just like an ambulance, you hear that. Well, the redshift is supposedly evidence for the Big Bang, and things are moving away. Well, the problem was when he found these peculiar galaxies and these quasars, that he was saying, you know, we're having a problem with the Big Bang now, because according to this, these things are attached, and you say the galaxy is moving at this, and the quasar is moving way faster, yet these look like they're moving together. How could that be? Because they have different redshifts. That is, the Doppler effect was they said was different. So they started saying, wait a minute, you're not only looking at peculiar galaxies, but you're making critical thinking moves and going against our Big Bang, because we are married to this idea. And so he eventually gets his telescope time dwindles until it completely goes away. We have other ones. We have Stephen Carruthers, who wanted to write his thesis in physics in Australia against the Big Bang, because he went through the all that complicated mathematics with Schwarzkopf about the Big Bang, about black holes. I'm sorry, not the Big Bang, black holes. And he says he wanted to write a thesis against that. Guess what happened? They drummed him out of the university. Dr. Riccardo Carruthers, he did one experiment. It didn't show his new equations that were better than Einstein's, but then he found out he didn't do that right. He wanted to do another one. He goes, no, you can't, because implications. Two kids that wanted to do another experiment by Carruthers were told if they wanted a career in physics, not to do the experiment, and they wouldn't do it at the university. I took the same experiment to TRW in Space Park, in a room full of 9 physicists, and there I am, who I'm not a physicist, and I said, do this experiment to show Einstein special relativity wrong. They came back and said, we couldn't find anything wrong with Carruthers' experiment. It looks like it should work, but we don't do that. And Dr. Bill Lucas was one of the greatest minds in physics, and he did a paper saying relativity has got problems, and then from that moment on he was kicked out of the entire program by the United States government, saying you can't, do any of that. So that's what these are going to be, fights from physics. Another one is our stories. If you go to stories, you'll see the 3 categories, and you'll see here's fights from physics. In physics, eureka moments. My dad here accidentally solving the wave-particle duality. That was a eureka moment. Dr. James Maxlow for expansion tectonics. In fact, Fractal Lady, we were all there, and we gave him a Lifetime Achievement Award. For those of you who don't know, it's expansion tectonics, and expansion tectonics says the Earth's been expanding, and he didn't believe in that, because he was a regular geologist, until he realized that the South Pole, when you plot it here, the paleo South Pole, here's the South Antarctica, right there, on his globe that he made for me. I feel very honored that it moved up. That actually it went from Africa here, and it eventually moved down into Antarctica. Now, it wasn't that the these things, oh, that's Australia. Hello, there we go. Get it right, Dave. There's Africa, and there's Antarctica. Well, the South Pole actually goes from here in Africa and moves its way down to Antarctica. Oh, boy. You can't, doing something backwards in a mirror is almost like impossible. I have to learn that. And there's Antarctica. So it goes from there. And when he plotted it on an expanding Earth, according to the expansion tectonics, guess what happened? It perfectly fit. And that was a eureka moment for him. So this was actually suggested by Nick Percival. If you go to Nick of Time, if you go to my YouTube channel, he is a great guy who talks about time and all that stuff. He is from Harvard, I believe, and he is the guru on time. So those people interested in time, look at him. He even talks about time, and he was the one who suggested these eureka moments. And of course, we have the big picture. I'll just go to here. I've already written a bunch of these things because it's really important. If you are new to science, the first thing you do is, there are problems in science? I thought everything was right. Here are things, how big science fools us. That is, how they tell us everything's okay. See, it says, big science, big physics, and big cosmology sell themselves, and their theory is that only geniuses should apply. This is what I was talking to you guys about. Why mainstream science sees no crisis. I'm writing, most all of these are mine, but that's okay, because I'm writing the big picture ones. Become science woke. We talk about that. Universities are failing at science education. Here's a sign up. I can't challenge Einstein at my university, which is absolutely true. It's absurd that you can't do that. Imagine, we're in the 21st century. We supposedly are very advanced, and we don't allow ourselves and our students to even challenge mainstream anything. Why are we the best scientific society on the planet? Here's why. People in my own society, or the CMPS, argue with me. Well, It's a bold statement. Let's see if I actually wrote something on this. Oh, I did. It's a pretty bold statement. CMPS is the best scientific society on the planet, period. And we can tell you why. We are the best. Why? Because we try to submit a serious paper of any of the following subjects to any scientific group or society. People, not a website. You know, there's websites will accept any of them on the planet. Or better yet, try to write your master's or PhD thesis on any of the following. Arguments against the Big Bang, evidence against relativity, evidence that the Earth is expanding, new model for light, a new model for the atom, a new physical model for the entire universe. If you do, you will be rejected by them all. So the idea here at this whole Science Woke website is in fact to get, oops, this is the dashboard for it, because it's is in fact to get people to understand where to start. Where do I start? Start here, becoming science woke. That's a good one. So we'll tell you the problems in science. People say, what do you mean there's problems in science? Well, you can come and click on it. Well, we'll click on the Big Bang here. There's problems with the Big Bang? Well, you can click on that and come here, problems with the Big Bang. Severe, fatal, mind blown. The Big Bang is under attack and is being abandoned for a steady state universe. Redshift is really the problem. Other explanations for redshift, galaxy distributions don't support the Big Bang. We had a paper. I don't think Fractal Woman was our last conference, but we had it at the University of Connecticut, our last conference this year. And Ray Gallucci talked about the distribution of galaxies in the sky. And guess what? They do not fit the Big Bang. They fit like they're evenly distributed. The Big Bang would not have evenly distributed. So very interesting. And here are all the abstracts. We have 57 of them in our database. So we have a big database of information. So this is our idea, new theories. You can see our new theories, people here. We have a lot more than are here. My father and I are working on one of their universal cycle theory, autodynamics. You have the infinite universe, energy wave theory. Look at this. Fractal, are you still there, Fractal lady? Yes, you are, Fractal woman. There you are. Fractals and black holes. Generator fractals resemble many observed galaxies, which is really interesting. And actually, when I first met Fractal woman, it was really interesting that, let's see if I have anything on her. Now, see, I want you to work on it. It says, the Mandelbrot set as a quasi-black hole. Premise, novel black hole theory. Generated fractal type fractal cosmology. And I put a little bit there. Now, I look at all this stuff. She even has papers on it because she goes to our conferences. But when I had talked with Lori and she was talking about, you know, how these galaxies resemble fractals. Now, fractals are made by repetitious pieces, and those pieces having pieces, etc. Well, normally when we look at fractals in a way we're not gonna see it infinitely down. Our eye doesn't see the line here in a fractal and all the pieces of it. We only can see to a certain, what I would call a certain resolution. And then if we, computer-wise, you've probably seen those great videos, and I think she has videos, Lori Gardy. She has videos on this, and she, when I was talking to her, I got this idea. You know why they're like that, why you have galaxies like that? Because the processes of everything that makes up a galaxy are similar processes of similar scale and similar resolution. And because of that, if things happen in certain ways or certain motions, those things are going to be repetitive. And some of them are probably even strung off of each other. I mean, think about it. Galaxies, I mean, why are all these things together? We don't really know. How do these stars, you know, happen? Do they all form in these, we know, maybe there's some new theories about that. Maybe even Lori has those. But it really got me thinking about how fractals really appear in the resolution of what we see, because we can only see so far. Our world, we only see so many levels. There's, I believe, infinite levels up and infinite levels down. So anyways, those people who are new, who are coming from, I appreciate, there's yeah, Lisa's bringing some new people. I appreciate people coming by. If you have any questions, and let me go back through the questions now and get to you. But I think that's really exciting. This is coming along. I fill in. We've got lots to fill in, and I'm going to have people working on those articles. And then when we get to a certain point, we're going to launch. So let's see here. My goodness, I appreciate everybody. Whoa, look, there's a lot of people stimulating. Okay, good evening. How about the crater found in Greenland? Interesting that Jean Patel was entirely self-taught as physics as well. Yeah, forget what his, I can look him up on our wiki.naturalphilosophy.org, and I believe he got his degree somewhere not too shabby. Chappelle. Let's see here. John Chappelle. John Chappelle was preeminent among the seeking clarity. So if you don't know, wiki.naturalphilosophy.org, that's where you're going to find everybody. That's our idea. We've got about 10,000 pages on it, so we do have a lot of information there. A lot of it is incomplete. You want to help? Let us know. John attended Harvard University, received an MA in history from the University of Berkeley, attended University of Washington, Seattle, received his PhD from University of he taught at the university, so he was in the university area. But yeah, absolutely, we got a lot of this information. He was really the founder. That's why we call our society the John Chappelle Natural Philosophy Society. We want to make sure he was linked to that. Again, you can go to wiki.naturalphilosophy.org. Thanks. Most of my head is really, really interesting. For me too, Lisa Baba. Kath, Dave, and his father have a different model in terms of the universe compared to what the mainstream says. He's okay. There'll be more than one. Absolutely. Absolutely. We should have as many models as we can. The more models, the better. Why? Because we got to keep thinking outside the box. If we got to understand that, why do we have more than one human language? Why do we have a ton of computer language? Why do we have like 6 operating systems that are very common in the world? Why don't we have all one? Well, we can actually have, we do have equations. I'll give you a good example. Computer models for molecules. Computer models for molecules do not use quantum mechanics. They don't use quarks. They don't use any of that stuff. They have absolutely really no idea how charge or polarity works. What's polarity? Well, when you put atoms, suppose you have charge because there's electrons and positrons. That's according to the standard model. Other models like ours, we don't need charge. But anyways, you have like these molecules, and these molecules will have a tendency to stick together, just like magnets. There's like, you can think of it like magnetism, almost like magnets. They stick together, all these things. Well, that part of it, all the computer programs that simulate you trying to build chemicals, if you're a organic chemist or you're whatever, you're in chemistry and you're trying to build new molecules, you have computers, programs that do it. They don't use a lot of physics. They have algorithms about how these things are. They just basically model them inside. This is what they look like when you put it next to this, and then they try to make some general rules for it. Those general rules work okay. They end up not always modeling really what happens in the real world. When that happens, then they will change their models and tweak them. But it isn't. It's like NASA. They don't use relativity in their models of everything in the cosmos. And their models, the computer models, are just really hacky when you really look at them. They use Newton's laws. They use and then they try to update. They basically look at things again and they double check and then make adjustments all the time. And that's how they have their model of the universe. It's very haphazard, the entire thing. So we don't have physical models of the universe, so we need people coming up with them. And that is absolutely great. I'm going to talk a little bit about that today, about my father, what we're doing. Nothing special about having a high IQ. Absolutely, exactly. I mean, you can be really good at taking tests and having a high IQ. I think to me the people that I most admire, because it's more like me, are people like people who are artists and scientists. Those kind of people appeal to me, like Michelangelo or something like that. You know, he was thought about, you know, engineering. He also was an artist. So, you know, it doesn't mean I'm that. No, it just means, you know, everybody has their skills. Everybody has people that they look up to. And, you know, if they give something to the world, who cares what their IQ is? Reading through, engineering is the closest thing to real science we have today. That is really true, John Owens. I don't know if you're here anymore, but in fact, if I were to one of the things I've said, and I've been a member of this organization since 1996. Wow, over 20 years I've been with this group of critical thinkers, and the number one thing I've noticed amongst them, the best people, the best critical thinkers, you know who they are? Engineers. And you know, out of that group, who are the best? And I will tell you, without a doubt, this is my own opinion, electrical engineers. Almost every electrical engineer I've met in our group has had an amazing, you know, this is all what we think's going on, but man, it's just, it ain't, you know, it's the best we can do. But we can do better. Don't take anything that we're doing as gospel. It's good, maybe. It works, maybe. Engineers, absolutely. Richard Feynman, he tries to make it simple for people. Yeah, absolutely. I know my father is the same way. I think that's one of the things I like about his talks. Particle.guru. Go there. Not .com, .guru. Or YouTube.particle.guru. Yes, no com, no www. No. YouTube.particle.guru. I love that book, yeah. At least don't be afraid of physics. That's right. Like David says, we need to simplify. Absolutely. Simplify. In fact, my father and I have a model that makes the entire universe, everything physical. So gravity's physical, light's physical, magnetism is physical, everything's physical. Everything. You know what it's made of? Moving particles. All particles are made of other particles. This isn't like they're all round or something. That's not what we're saying. And we do it with basically one equation, which is kinetic energy. We do the entire universe with that. So we don't need quantum mechanics. We don't even need charge. You know, why does an electron go around a positron? Why is an atom made of a nucleus and something goes around it? Well, because the electron's negatively charged and the positron's positively charged. What does that mean? Well, in our model, it doesn't mean anything. It's just like orbit. Is the Earth negative and the Sun positive? No. But somebody way up there, maybe in the world that we're part of a chair, that like the solar system is a barium atom or something like that, which some people say it is, then basically the people up there are saying, oh, look, the Earth's negatively charged and the Sun's positively charged. So there you go. It would help me if it was simplified. Yeah, Kathleen, absolutely. There we go. This is what I'm trying to simplify. Okay. It's a quantum mystery. I am trying to encourage more women to become more interested in physics. Absolutely. Well, guess what? Our chief scientist, let's see if I go to this page. I'm going to go here. Naturalphilosophy.org is our website. Why natural philosophy? Because that's what we called physics before it was physics. And the reason we say natural philosophy because we want to get away from the modern physics. Let's see about CMPS directors. For those of you who are interested in women in the field, take a gander at this. Who's at the top? Oh, where am I? Hello? Who's at the top of the page? Chief Scientist Cynthia K Whitney. Dr. Cynthia K Whitney is an editor and publisher of the Dissident Physics Journal, Galilean Electrodynamics, and the proceedings, and for the Proceedings of the Natural Philosophy Alliance. That was before we changed our name. She earned 3 degrees at MIT, a Bachelor of Science in Physics, a Master's of Science in Electrical Engineering, and a PhD in Mathematical Physics, specifically in Special Relativity. She is our chief scientist. Do I care about she's a woman? No. only to call her Mrs. But I don't even care about that. She's a brilliant person, a wonderful person, and it goes to show you that, yeah, she's the only woman there right now, but this is an old list of our people. But we have other women in the group. Some of them have passed on. The other person that was really prominent in our group, and the president of our group for many years, was Dr. Eberly Spencer. I can go to the wiki, go there. Spencer. She was prolific. See my movie, EinsteinWrong.com. EinsteinWrong.com. Dr. Eberly Spencer, Domina Eberly Spencer. Born at MIT. A woman who got a PhD in mathematics and a Bachelor of Science in Physics, and in 1942. Now think about it, folks. 1942, women were not exactly welcome at these universities, and she got her PhD in it. And she's in my movie and stands in front of the camera and says, Einstein was wrong. His two postulates were wrong. I'm going to do her accent. Sorry, it's really good. She's American. She was born in the United States, and she wasn't even a place. Don't ask anybody where she got that out. They were wrong. Einstein said the speed of light was constant, and it is not. And he said that, what was the second one? Speed of light was constant. Oh, and Maxwell's equations were correct, and they aren't. She says it that way. Brilliant lady. So there you go. Two brilliant scientists who happen to be women. No offense, I don't care. They're just brilliant people. Really enjoyed. And for those of you who feel intimidated, do go to, I will put this up here. This is a great movie. I made it, but that's not why I'm saying it. It is a great movie because I had great people. I had great editors, great subjects to work with. So you want to go to this, EinsteinWrong.com. For $3, you can watch it online. I do have times where I give it away for free. If you look at some, there may be even some left. I put coupons out there, but it's only for $3. You can watch it. It is a really great, fun film for those, and it's for general audiences. You have to know nothing about physics. Absolutely zero. In fact, I can play you the trailer just for fun. So those who are a little bit intimidated, here we go. Let's see if I can do this here. Oops, don't want to do it that way. Okay, I'll do it here. And let's see, I should be able to mute myself, so you're going to hear me muted, and hopefully you'll be able to hear this. We'll play the trailer, which is only 1 minute. And for those, again, who are becoming science, won't want to be intimidated, I took my mom. The whole premise of the movie is I took my mom, who was a suburban housewife, God bless her soul, and she was taken around the country and meeting people and even phoning them on the telephone to find out if Einstein was wrong. And she was absolute complete layman, much less technical than I am, but very bright, like I'm sure many of you are. So let's take a look at the trailer.
Ladies and gentlemen, boys and girls, what you're about to see is out of this world. Step right up now, don't be shy, because we're about to show you how cars can fly.
You heard the title, Einstein is Wrong. So we want to know if you agree with that or disagree with that.
Yeah, I very much disagree with that.
Every day I see a bright blue morning, the sun shining as the world wakes again. Hey mister, can you tell me, does space bend?
Speed of an object with respect to an observer who is off the line of motion to the object. Whoa!
Joyous people celebrate
No clue.
life so grand. Hey mister, read that fairy tale again. Ooh, I've seen it, though you won't believe it. It's a miracle year in which we're living. Come on outside, it's a beautiful day. It's a beautiful day.
So there you go, trailer. Oh, like the music. My friend, very good friend, is composer. he wrote that music, and he actually wrote the words to that. And I actually got funding for the film. For those who want to know, it was about $150,000 of investment. I put in a bunch of money of my own, which I didn't really have, but I put in there. Took about 8 to 9 years to make. It was made completely for the general audience. The reason it almost made it into the Oxford Film Festival. It was sent to all the major film festivals, over 80 of them worldwide. Didn't make them into any of them. It made it the finals into a few of them. Most of the people said they didn't want anything controversial, and a lot of the intellectuals who just couldn't accept the idea of having something talking about Einstein being wrong, because a lot of people who run film festivals are intellectuals, and their whole goal is not to be smart or be critical thinkers. It's to appear smart and be able to repeat, just like Neil deGrasse Tyson does, repeat what is said and not be a critical thinker. But for those of you who are not, who are new, like some of Lisa's friends or other people, check out the movie. Watch it. It's extremely entertaining. I have screened it to many different audiences, and we had a big screening night, and got a standing ovation, and we got people who never saw anything or even cared about science or anything going away going, oh, I didn't know that. Einstein could be wrong. So it approaches it and explains things in a very easy terms. It's got great graphics. Original music. It's got a music video with that's a lot of fun, and it's probably the only science documentary to have a theme song, so it's pretty cool. All right, time can exist without space, you can imagine. Okay, that's she's talking about it. All right, no, not Amazon. Yeah, I understand. Amazon is a scourge. I'm sorry, I'm just showing the books. You're totally right, though. I agree with that. These hearts and hugs. Oh, Fractal, I just joined the channel. Okay, good. Her channel, good. Movement is one form of change. Yeah, movement is this whole idea that time is movement. Change can come from anywhere. I'm reading through just to make sure if anybody has a question. Lisa, question: what exactly is it about the electric universe theory that bothers you the most? Thank you. Is this for me, or is this for I think Lisa's I think you've asked that before. I know Dave is really prolific in his reading. I'll get back to that. I think it's important for her to read everything and then make a decision. I love Laurie Gardy. She is great. I love her. Great thinker. Great conversations we had in the car in Vancouver, driving around to dinner or something like that. Oh, I'm here. That means I was talking about it. I love the term science woke. It's a brilliant form of marketing prospect. Woke is the new cool, is the way. Yeah, you know, it was Lisa. I think it was inspired by Lisa because she came to me and I think it was Lisa who said to me, and I'll never forget this, hey, you know, I knew big ag is screwing us over, big politics are screwing us over, the rich are screwing us over, all these kind of people, all these. What about big science? Are they doing the same? Yeah, it's a little different though. I did start to talk about it. The difference is that it's not a money thing. It has to do with nerds and people. The nerds were put into a very important position politically, and that is they are the ones who do atomic experiments and smashers and the big colliders, and people in countries are worried that if they don't do those colliders, then they're not going to have it, and that's going to be some type of world power. That's how they get it, and they wield that way, and they get their money that way. The nerds who were picked on, like myself, I was one of those nerdy kids, smart kids in school that was picked on by the bullies. I was a pacifist. I fight back and all that stuff. I actually did think, I've told this story before, I remember 7th and 8th grade being picked on. I said, you know, someday I'm going to be a scientist and come up with some theory, and they're all going to have to bow down to me or something like that. I mean, it was emotional, and a lot of the nerds, that's what they do. They get picked on. Maybe they're a little bit autistic. Again, I'm not criticizing. I think I've got autistic tendencies, and because of that, they want to be accepted. So when they go back to their high school reunions, they go, "What are you doing?" "Oh, I'm a salesperson from this," and that's the jock from the soccer team or the American football team. And then they go to the nerd who was nobody. Says, "What are you doing?" "Well, I'm an astrophysicist from MIT." And everybody's like, "Oh, the guy knows the universe is so smart." And, you know, that's and that kind of control continues, and anybody who goes against that, you know, gets in trouble. So it's a very different world. This house of Tim Canova was robbed and cheated. Boy, I don't want to talk about that because I have another channel that has to do with science and progressive. But anyways, that's what I'm going to be launching once we get Science Woke done. I've got my next project ready so that I want to try to get into all those channels and try to get those progressive woke, those politically woke people to become science woke. So that's the idea. And Tim, yes, basically what happens is we need to do like most other countries and take away the machines that count votes because they're completely manipulative. You can manipulate them. And basically this election for Debbie Wasserman Schultz ran against Tim Canova. The exit polls and Gallup polls by Republicans showed Debbie Wasserman and Tim Canova neck and neck to the very day of the election, and then she won, and they dialed into the votes. They literally changed the vote counts. She got like 58%, the Republican 30 some, and Tim 5, not even 5%. It should have been more like I think it was running at 38% and 38%, more or less. The polls had them neck and neck. Well, Tim Canova found the counts of votes that were cast, and there were 97,000 that they couldn't be accounted for that were attributed to Debbie Wasserman Schultz. And of course, we have people who wash up on shore with bullets to the head in Hollywood, California, in Broward County, who are working against the Democratic Party. It is terrible down here. It's terrible. Oh, I know there was a question about the electric universe. This is the paper I presented. Okay, cool. James Maxwell is awesome. Absolutely. His theory is supported by the fractal paradigm. Super. Expanding universe, zooming into fractal. There is a big fight between Dr. Walter Lynn against electric engineers. He shows that Kirchhoff's law. Very interesting. My father is coming up with some experiments, hopefully by the beginning of next year. He's an electrical engineer by trade, 40 years, brilliant electrical engineer. And our particle model describes things and will actually show that the electrical engineering equations are not that precise, and that our model will show this. The Earth is expanding because the measuring stick is decreasing. Yep, that is an idea. Resolution is a key word. Thank you, David, for pointing that out. Hey! You're welcome. And you were thinking about rebuilding your organization devoted to autodynamics. Any plans on promoting theory further? That's Tyler. Tom, I don't know if you're here still, but that's okay. I know that people have to go in and out. Still got 9 people here. That's great. So the autodynamics, if you haven't been to that, it's the work by Dr. Carruthers. Yeah, I was planning to do that. We are doing that. So the answer to your question, what are we doing with autodynamics? We are continuing. In fact, because of Dr. Carruthers' work, here's autodynamics in one page. Our particle model is based on him. In my opinion, it's a continuation of Dr. Carruthers' work. So absolutely. I think the guy is a brilliant guy. I think he, in my opinion, had took special relativity and put it back into the Newtonian world. He points out very clearly where special relativity goes wrong, both mathematically and conceptually and or physically, and with his equations, his more Newtonian equations, he can describe things more simply without the neutrino, for example. So in all those collisions, when they collide in colliders, they collide particles together, and they say there's this magical particle called a neutrino. You don't need that. Simpler works. It's called Occam's razor. That is, simpler idea should win. And that's one of the things Unscript talks about, and that's one of the things we're trying to talk about here, is these models the new models are simple. And because of that, we have simpler answers. And Carruthers definitely there. So Carruthers came and untied the Gordian knot that Einstein had tied that was wrong. We were trying to make a certain type of knot to make ourselves go forward in science. He did it wrong. Carruthers moved us back to what makes possible, for instance, our particle model. Based, and he called the graviton model, but my dad has gone beyond that with the wave-particle duality. Anyways, absolutely, his work is there. Great man. Oh, we got 150%. Oh, maybe it's easier for you guys to see that way. Okay, autodynamics.org. His side of the debate is the YouTube channel Lectures by Walter Levin. They will make you love physics. Okay, I'll check it out. One of the largest EE pushing against him is a YouTuber known as Electric Boom. Robert Dissident, yeah, she's talking about that with people. That's good. Kirchhoff's whole disagreeing with the master. Harp realized quasars and quantized redshift patterns that are cyclical method for new stars. Yep, and Halton Arp was basically, this gets down to the whole thing. Well, the Big Bang was even postulated because they saw redshift. That is, the light they saw from the stars, galaxies, all those things, quasars, were not the color they should be. They all seem to be shifted to the red. If you look at if that was traveling, then that you would say that the frequency then was shifted to red because it's a longer frequency. When you're moving away, that frequency then gets longer, so what you see is shifted. And they said, oh, that must mean everything is expanding. Oh, there must be a Big Bang. But there are other explanations for what we call red shift, and that's what Halton Arp was getting at. Oh, there's Cosmology Quest. That was one thing. I've got to talk about that for Cosmology Quest. I know the guy who did it. The Cosmology Quest is a documentary about going against the Big Bang and Halton Arp. So look that up, Cosmology Quest. I'll actually look it up. I talked with the maker of that film. He's actually a composer, an American living in Italy who does composing for films in Europe. And he has made a lot of money doing that. So he made his own documentary. And I will tell you, and on filmmaking, on a scale of 1 to 10, it ain't gonna win awards. If you watch Einstein Wrong, you'll be entertained even if you have no idea what people are talking about or no interest in it, because there's a great human story to it. That's why it's called Einstein Wrong, The Miracle Year. I had great editors from Los Angeles, California, Hollywood area who made that into a great human adventure and story. Cosmology Quest. Man, I got so much stuff. There it is. I'll just put it on the IMDb. There it is. Cosmology Quest. A group of renowned cosmologists and astrophysicists are in search of a realistic picture of the universe. Their research and observational discoveries point to a direction dramatically opposed to the predominant big bog bang theory. Big Bang Theory. This leads to a series of sociological situations that verge on the extreme dogma controls wielded against Copernicus and Galileo in the past. So they talk about these struggles. Here's another person who's struggling. Of course, it's what I talked about, Halton Arp. This is a controversial science documentary touching on the nerve of everything astronomers and cosmologists claim to know about the universe today. Randall Myers, composer. Good guy. Talk with him. That's one of the great things. I've hung out with all the smart people. Okay, I appreciate people coming by. I will talk, because I always have topics. It's 10:15. I'm going to talk for probably at least 15 more minutes. And I wanted to touch upon a conversation I had with my father today. What is it like for, and you know, one of the things I'm going to be talking about in my videos that are more, you know, recorded is our particle model. Not because we're going to tell you that it's right, because I think it's one of the best models out there, but it's not because we're making it and I'm emotionally attached to it. It's because all the things I thought were wrong with models, I was able to put what I thought was the best things, the eureka moments that I had seen, together with my father, and it just sort of came together. So, but regardless, here are two people, myself and my father, who are working on a model, and we have conversations all the time. I'll give you, what is that like? Well, our first year and a half was just a whirlwind. I mean, we were like the first people to have rock and roll in our hands, so everything we wrote was new. So we were hacking the universe. Dispersion, the one that it took a while to do, is you have a triangle light. For those of you who don't know what dispersion is, it's the famous you know, I think it just goes to that size. Dispersion. What is a rainbow? Anyways, it has to do with the rainbow from prism. You know, the prisms that you see. There we go. Take a look at this. This is a good one. My dad works on these things. There we go. Whoa. See, I can make this smaller actually. Can we just see this one? It probably goes to the page now. I'm sorry about that. Anyways, there you go. You see here that white light comes in and a rainbow comes out. Now that's not an easy thing to actually come up with the reason why that happens. And my dad and I were working on our own particle model, and we would have discussions about how to do this. It took us a year and a half with our model to try to figure out why this was happening. We know what, in our model, we know what we call light, what we have physical light, or waves of particles, not waves in particles, but waves of particles, and why. And it turns out we had to describe, and the hard part was, and sometimes my dad would come up with the answer, and sometimes I would come up with the answer with our model. And it turns out that if you do this with a rectangular piece of glass, there is no rainbow. There are no colors. It comes out, goes in white, comes out white. So there's a reason, must be a reason, physically, why a non-parallel surfaces do that. And it turns out that the answer is the mass. So you have more mass here than here. And we explain that in our model, how that works. But when we have conversations today, we're talking, you know, my dad will come up to me and say, and I say to him, you know, somebody wanted to know why the G2 particle in our model goes at c squared. And then he starts talking about inertia. And we talk, the thing that makes our conversations different is that we talk about everything using our model. And so we do that because our model is supposedly able to describe the whole universe, so we should be able to describe things like inertia. And inertia is, again, that idea that this, if I put this in motion, a body in motion will always keep in motion. Well, what's keeping it in motion, or is there something that's going to resist it? And so he was talking to me. He was trying to put together these new talks, and he was describing how that is. So what happens is when you have your own model and you're talking with somebody else, I and my father have a huge advantage. Not because we're smart. Nope, we're no smarter, dumber than anybody else. Not because we're right. Nope, we don't know if we're right. We have no idea if we're right. But we do have an advantage that we have two of us working on the same model, and we both seem to have the same proclivity for mechanical models. That everything, what I do not like in people's models is that they have magic in them. What's magic? Charge is magic. Electric fields are magic. They're not magic in our model. So when we talk about the universe, we talk about it in terms of everything's physical. Everything is physical. Everything. You can't have two magnets next to each other pulling themselves together and you're holding them apart without a physical force there somewhere. It's not magic. Oh, it's just it's a magnetic field. And one's charged and there's positive, negative. You can't just draw pluses and minuses on things and they just come together. It's magic. So one of the things my father and I have as new model builders of the way the universe works is we cannot ever accept the idea that something does something without some other physical explanation. And that's where infinity comes in, because if you have light and it's bending, it's waves of particles, and those particles like go around, they curve, light will bend in masses. Well, there's something doing that, and there's something down a level. There's a second level of gravity doing that, and then there's a third and a fourth and a fifth, infinitely down and infinitely up. This is where Lisa talks about her fractals. Very similar. Fractals are infinite, up and down. Absolutely, she'll be the first, I'm sure, to say that. And so when my father and I are talking, we have just a wonderful time, because a lot of times, I don't know if Lori Gardy, Fractal Woman, has another person who subscribes to the model and is working on it with her. When you have a second person, you not only have somebody to support you, but you have somebody to be able to talk about ideas, and that person understands them. We actually have a third person that subscribes to our model. He is a guy that I work with at work. I work in the supercomputer area, and he's a Brazilian guy, and he happens to be the same way as us, and that is everything in the world has to be physical. Stop telling me there's magic fields and magic charges and magic this and magic that. And that gets me to another question, which is, I think Lisa asked, and she's asked this before, what is my objection to the electric universe? It's not that I have an objection. It's just it leaves me. It's sort of like, again, this is not a criticism. It's sort of like religion. If you're a person that believes God created the universe, and you have absolute right to that, I do not criticize anybody for that. I can't even say that is true or not. But you have to understand, then that person describes everything that's going on. That will answer all your questions. Well, that's the way it sort of looks with the electric universe. It's sort of like the electrical part answers all the questions. Charge, traction, the electric field, it describes everything. And the only problem I have with that is, what is that? What is that made out of? And it's like having an ultimate particle. So, when they talk about how the universe is electrical, gravity is electrical. What's the model? What's the physical model for it? I think the way I look at it, in a positive way, because I absolutely applaud them. I do not in any way talk bad about the electric universe. How can you talk bad about an organization whose goal is to turn people into critical thinkers, to go against mainstream and to actually think on their own? A lot of people in that group, and I've talked with many of them, dozens of them personally, for at length hours. They don't all subscribe to everything. No one in our group subscribes to everything. There are people who believe special relativity to be right in a group. But that's the thing. We have to allow all that. And I have to respect that. because who's right, who's wrong? As Neil Adams, the guy who does the Expanding Earth, look up Neil Adams, watch his videos, a must. And as he says, we all are part owner of the truth. So, wow, YouTube let me put a link. Yeah, absolutely does. Electric universe and plasma physics. And again, so my problem with electric universe is I want to know what the electric field is. I want to know what the electric charge is. But the way I look at it, I sort of got a little off track. The way I look at it is they concentrate and say, let's look at how far the electrical processes actually are part of this universe. Maybe they're doing a lot more than we think. The Grand Canyon, they say, was made by an electrical process, a catastrophic process. And these are theories like everybody else's. Do I subscribe to that? No. I think the Grand Canyon was formed because the Earth's expanding. And I think the evidence for Earth expansion and growth, more mass, is quite large. But could they be right? Absolutely. Absolutely. So I look at it as they have explanations for the sun, for the way comics works and other things, and made predictions, like flashes when something hit a comet that would be electrical because they're electrically charged. Yeah, there's a lot of great work coming out of them. There's what they do. When I start yawning, it's time for everybody else to start yawning, and then me to almost get on way. I know I got it maybe about 4 or 5 minutes here. But again, I absolutely applaud the electric universe. I again think that sort of like who made the universe, they don't seem to be telling us what those electric fields are. A lot of people don't. A lot of models don't tell you what electric magnetic fields are. They don't tell you what an electric field is. They don't tell you really what light is. They don't tell you really what gravity is, although the electric universe people are trying to describe it electrically. But again, and they're describing it electrically, they won't tell you what about the electric part. So they're just saying everything's based on that. And that's my own curiosity saying, I want more than that. But they are making critical thinkers. So I absolutely support them. If that's your bent and that's the thing that really makes you understand the universe better in some way, go for it. Applaud. I'd give a talk at their conference any day. The first thing that'd come out of my mouth is, this is a great organization. You guys got great marketing. The idea that you can be a critical thinker and go against the mainstream and think on your own and not accept what and look at the electric universe yourself. My dad and I are still working on our model, and I hope to do some more videos. YouTube.particle.guru, a couple videos coming out. We just click on it, subscribe to it. Some videos are coming by that are going to be well worth it. And not just because of my father, but when he told me he's had problems with the computer, he had to get a new computer, redo the whole thing, so he's been a little bit behind. But very, very well worth it. And I know Fractal Woman has a YouTube channel, and of course Lisa has a YouTube channel for those into sort of a daily blog diary of random thinking of and discussions. I really like her politics. I like her open-mindedness. Very interesting. I'll tune in when I just want to hear somebody chatter about the world in an interesting way. I tune in. So I don't know if she's listening, but let's see here. Got some more people here. You have ever heard of the theory of Planck's stars? It asserts that black holes, the notions of infinitely small hyperbole and such insight comprises of mass bouncing around, and I'm with you on EU theory, although I like electric scarring creators being caused by super lightning. Yep, that is definitely an idea that should be looked at. That the mass gains amplitude of electric absorbed from the light, blah blah blah. Okay. And, well, it bounces again. I guess talking about it, you gads know. Did say something that was... oh, yeah. Talking about playing stars. You got to be very careful when it comes to infinity. Read Glenn Borkert. The way I would say it is a lot of people have their own sort of folk idea of infinity. Glenn Borkert, and if you really want to look at the mathematics, the real mathematics of infinity, I recommend Peter Erickson, my favorite mathematician on the planet. Some people called him crazy, but guess what? He's crazy good. This is his latest book called The Nature of Negative Numbers. And I want to make a t-shirt. The square root of -1 times the square root of -1 equals -1. Now, if you're a mathematician like me, that's like equals MC squared, but it's equals MC squared is sort of somewhat vacuous. My father was talking about that. Anyways, I got people coming in and out. If you have any questions, I can answer them. Again, I appreciate everybody coming by, getting more people, and I appreciate people talking about the channel, getting people to come by, check it out, because my goal is very different. I believe in I think Dissident calls it polytheism. I like Dissente's work. I try to talk with them, but a lot of times Dissident and those guys, I find them to be, they're cool by themselves. They're not a whole lot of interest in necessarily joining up with others. And I'm the opposite. I want to know people. I want to know why they think what they think. Why did you spend your life coming up with this theory, with these ideas? I mean, people spend, this is what I always sort of give people the benefit of the doubt. Why would this person, who I consider to be pretty smart and brilliant, spend all this time on this? I want to know why. And even though I may not agree with it, it brings super insights to me and thoughts about stuff I never thought of myself. So that's really an important thing. And you know what? I didn't even get to my website that I wanted to talk about. I'm going to make one of the guys I talk with on Monday. We got in an argument. He actually works next to Fermilab, I believe. Is that in Chicago or something like that? I'm not sure. Don't quote me on this stuff. I'm terrible with names, locations, you know, unless I'm really intimately I visited the place. But he has this. We were talking, and he was saying, Dave, the only thing I don't like about you is you just talk so bad. You talk trash with people in mainstream. No, I talk trash not on the people in mainstream, about what they say and their illogical things. And I laugh at them because when you take apart, one of the things you guys you want to do is take a look at the articles that come out, and I go through them literally almost line by line, and I point out to you how to be a science critical thinker and show you the nonsense that they talk about, because they contradict themselves. They talk about, they use all these fancy words, and you can see where their arrogance is. You can see where they don't listen to other people, where they don't listen to criticism. Yeah, I get on what they say. I'm sure they're great people. You know, that's one of the people, well, my friend works in particle physics. He's a theoretician. You're telling me that he worked on something for 35 years of his life that wasn't anything? You know what my answer is? Yep. It's hard to believe. But there are a lot of people who work their entire lives as master craftsmen. One of the most important jobs in the 16th century, 15th, 16th, 17th century was carving rock. Why? Because all the big buildings were being carved by rock. They were sort of like the rock stars. No, I'm kidding. They were sort of like the computer programmers of their time. They were the ones who could calculate things, make arches, put forces, make art at the same time. Where are they today? Just because you spend and you have thousands, hundreds of thousands maybe, of people working in an area, but in physics you don't have that many. Theoretical physics you're lucky to have hundreds worldwide. Those people, yeah, they're wasting their time. They know it. Deep down inside, they know it. Because whenever you get close to them and you talk to them, like, look at Alexander Unsker. Look at my latest video. David somebody. Look up Dissident Science David as Unsker or whatever. You'll get a video of this guy, and you can see the way they're really, the way they talk. It's their attitude. It's what they say. It's the nonsense that they say. It's not the people. But, you know, anyways, that's very interesting. Still got people around. It's hard to take off, but he did point out a pixel lattice theory. He made a website, so I'm going to make a video on that. But anyways, I'm going to head off if there are no more questions. If you have none, I know it takes a few seconds here for people to see that, because I do have my phone here so I can see. There's a delay of about up to 10 seconds, 4 to 10 seconds. Any more questions, comments before I leave? Give you a little time. 10, 9, 8. Let's see. I gotta see when that happens. There you go. Yeah, it's about 10-second delay. So when I speak and talk to you, and I say, are there any questions? I got to wait 10 seconds before anybody, but I see there is none. So remember what I say. I am not here to tell you what to think. I'm not here to tell you my particle model, my father's particle model is right. I tell you my opinion about things, but you need to read it for yourself. You know, like I say, take a look at books that I recommend to read. That I do. Make up your own mind. If you're interested, if you hear about the electric universe and don't know what it's about, go to their website, thunderbolts.info. Take a look at the people I'm talking about. Take a look at the Fractal Ladies woman's website. All these people. Jeff Yee has a great, nice theory. Really hard, if you're into real hardcore mathematics, check out Bill Lucas. So anyways, take care everybody. Remember what I always say, stay critical, stay thinking. I am David D. Hilster, your science therapist, trying to get you to promised land of being science woke. Ciao for now, folks. And thanks for coming by, Kathleen. Appreciate it. I hope you come back. Take care, everybody.